Hello, everyone, and welcome. This is Professor Thayer with you to continue on our discussion about functions. So let us go ahead and get started. I'm going to share my screen with you, and as always, you are free to follow along if that's something you would like to do. So up to this point, we have been talking about the overview of functions and how to define functions at the beginning of the week. We've most recently looked at the scope of variables, those global variables versus local variables, and some of the consequences of that. Shadowing, for example, when you have two copies of the same variable. And finally, we are going to talk about the Python built-in functions to round out this week, and then we'll pick up with some of our other discussion on these further points next week as we continue on in our second week of functions. So then, let's take a look at the Python built-in functions. There are a number of functions that are built right into Python that you can use without having to do anything in particular. We'll also take a look at how to import functions using the ones from the math module. I will mention that, of course, we are not the first program in Python, and there are many things to import into Python, but the focus of this course, of course, is to build it up mainly using the core Python code so that you will be able to make your own functions and share these. And so we are encouraging you to not be making use of all the ones that are floating around out there, some of which are of higher quality than others, shall we say. But again, of course, our goal is to work with those basic building blocks so that you get the foundation so that you can build your own. And then as you move into your final project, you're welcome to make use of others and to build into the existing code base. So some familiar Python functions that there are that we've already visited are type and print. Type will tell you the type of the expression to its caller. So for example, if you want to know if something is an int, float, whatever its type is, you can use type and then substitute in your expression here. And we have been working with print since the very beginning. You would do print and then put some expression in. It does take the input in the form of a string, and it will send a textual representation of an expression to the screen, and it will return none. We'll have more to say about the returns in a moment. So for example, here's some samples of this. You could do type of 13/5, which will always give a float, right? Because it's a regular division. And we could do print and then we have our print statement here with several commas in between where we are going to substitute in the values of the floor division and the mantissa, which will tell us about the remainder. And so print will then make that textual representation to show on the screen. There's also the input function in Python. This is very useful to working with Python because you may want to ask your user something about, what's your name, or how old are you, or what kind of car do you wish, or what would you do if you won $1 million? You need to be able to get the user to type something and then for you to be able to capture that information, and that's what you can do with input. So similar to print, input is a Python built-in function. Input collects what the user types on the keyboard and returns it to the program. You must use input to obtain the feedback that the user types. The input function returns whatever that user types. And using input is just like working with any other function. You must capture what is returned by the function into a variable or use function composition to make use of information typed by the user. So we'll capture what they type and we'll save it into a variable. The input function itself takes input. It takes the prompt, which it displays when the program executes to prompt the user what they ought to type. So for example, it would look something like this. You would use the keyword input, and then you have your parentheses, and you would put some textual prompt here. If you didn't fill in the prompt, then input would be paused, waiting for the user to type something. But if the user did not get any message, they're going to be wondering why their program is paused. And this is why we need to put the prompt here. So we do input, and then we would put a prompt here, such as, what is your name? So here's some examples. We can use an input function with a variable. So we could do something like this, name equals, and then we have the keyword input, and then we have our what is your name right here. And then we are going to make use of print, nice to meet you. Notice that whatever the user has typed will then be sent into the variable name. So name is going to capture whatever is coming out of what the user typed, which is returned by the input function by the code that is written already in Python. And so then it will print nice to meet you, and the name will be substituted in because the variable information will have been passed to name, which is now here. You can also use the input function with composition. So composition is when you have a function inside of a function. And in fact, we've done printing of the output of a function already, although you may not have specifically noticed it. We will have even more to say about that coming up. So we would do print, it is a pleasure to meet you, and then we have input, please state your name. So what's going to happen here? Well, just like order of operations, when you have something inside of those parentheses, that thing inside the parentheses is going to first get resolved, and then it is going to send that value out to the outer parentheses. So what we can see here is that input is going to prompt the user to please state your name, but that will never get printed because this is actually going to execute first, the inner parentheses. So it will prompt the user, please state your name, and then input will return whatever the user types into this expression so that it will then print, it is a pleasure to meet you, and the thing that they typed. So let's just take a look at the output that we're going to get from these. So here we see that it's going to prompt, what is your name? That's from this one right here. Name equals, what is your name? And we type Professor there. And that then will get sent into name because that gets returned by the input function into the variable name. And now it will print, nice to meet you, name. And we see the output of that showing up right here. Next, we move on to this code over here. It says print, it is a pleasure to meet you. Now, notice that you may be thinking that it's going to print this first, but it does not. And the reason is because of that inner parentheses idea when we have the input prompting the user first. So this part is like the inner parentheses and will execute first. And this is what shows that that is happening. And notice that the prompt is distinct from the one up above. So we are certain that it is coming from here. Please state your name, which it displays on the screen right here, not because it prints, but because it is the, because input is part of its execution will print the statement for the prompt to the screen. Its input gets printed to the screen as it is right here. Please state your name, and I type Professor there. And that gets sent then out to the outer function, that is this print statement here. It is a pleasure to meet you, and then the result of this has been substituted in, just like when you have the inner parentheses of a math equation that would get resolved and be the number, it would be sent out to the outer parentheses. This expression gets resolved to whatever I typed, Professor there, and that goes right here, and it's right, it is a pleasure to meet you, Professor there, and that is how that works. There are also a number of coercion functions. We've been talking about the types, and suppose you want to change the type of something. Python coercion functions attempt to convert the input expression into a specific type. So do you agree that it should be possible to change an integer into a float, right? So if you had an integer 3 and you wanted it to be the float, you could try to convert it into the float 3.0. So Python can help you with that. The name of the coercion function suggests the type to which it will attempt to convert the input. Some conversions are not defined and will result in an error. So for example, what happens if you try to coerce cat into a float? C-A-T. Well, that doesn't really make sense. What if you try to convert a float into a string? Well, that might make sense because we've seen that strings could contain numbers. So that could be a possible one. But there are going to be some nuances about this. Some conversions may produce surprising or unexpected results as well. We'll see some examples coming up. So here's the syntax of our various coercion functions. So stir, as you might suspect, will attempt to convert the expression into a string. Int will attempt to convert the expression into an integer, float. Similarly, we'll try to convert the expression into a float, and bool will try to convert the expression into a Boolean. Here are some examples being shown over here. We can do string of 8.65, which gives us 8.65. We can also attempt to do integer of 6.5, which we see does turn it into an integer. Notice that it completely drops the decimal value. It's more like a truncation. Here we're doing float of 3, which converts it into 3.0. See how the types are the new types. And you can do bool of 5, which gives us the answer true, which is a little bit interesting. I wonder how Boolean is parsing this information. So that brings me to those unexpected coercions, the Booleans. So Booleans have the property that they can be coerced into integers. Remember, Boolean is true or false. And of course, in computer speak, things all get turned into ones and zeros at the end of the day. And it turns out that Booleans also have the property that they have their integer equivalents. True is equivalent to 1 and false is equivalent to 0. So overloading of Booleans in the mathematical expressions is something that is possible. Some mathematical operators are overloaded to allow working with Booleans. Remember, we talked about the overloading of the plus symbol for concatenation with strings, and how we said that, of course, concatenation of strings could not be the same thing as doing 1 + 1, for example, in integers. That's because they have distinct code under the hood. And so the same thing is true for working with Booleans in some situations where it has been defined. Again, this is tapping into that idea of the object-oriented programming, where everything in Python is an object and therefore has associated properties with it. And so one can define such properties. And they are defined for some of these. The Boolean is coerced into its integer equivalent. So that's the thing about Python. It's sometimes attempts to be helpful for us. We've seen this with the print, how it will attempt to be helpful by putting in a space if you print something, comma, something else. That's a pretty helpful one. I can't see that that's too dangerous. But if you weren't aware of what's going on here about this coercion into the true and false, you might get a little bit surprised. And so this is called implicit coercion, when Python goes ahead and tries to do something even though you didn't tell it to do that. So sometimes it's helpful and sometimes it can be a little bit unexpected. So let's just take a peek at how this might be working. So for addition, we have true plus 2, and you look at this and you say, what is that? And so if you didn't know about the Boolean coercions, you would not understand this. But if we understand that true is just being substituted for 1, we would get 1 + 2, and then we have 3. Here's the subtraction, 2 minus true. What does that mean? Well, that means 2 minus 1. Here we have multiplication, true times 2, which is 1 times 2, and division, 3 divided by true, which is 3 divided by 1. Recall that division, regular division, is always going to give us a float, which we see is the case here as well. Now here we're going to try false. So false will get the value of 0. False plus 2 is 0 plus 2, which is 2. Subtraction, 2 minus false is 2 minus 0, which is 2. False times 2, that's 0 times 2. Anything times 0 is equal to 0. We see this. Oh, but now we have division. 3 divided by false. We substitute in a 0. Is division by 0 allowed? No, it's not. So we get traced back. We're going to get an error here, and it's telling us we have a problem with 3 divided by false. We get our 0 division error, division by 0, because we cannot divide by 0. It is undefined. So we will get an error in this case, not from the coercion, but from 0 division. So continuing on with the unexpected coercions, integers and the floats, the int coercion function performs truncation to produce the integer up to 16 places. Now you may actually get a little bit of difference on your different machines. So the number of decimal places it goes out to is basically going to be a really large point. This is, if you go up to 16 places, this is 16-bit. You may have up to 32-bit on your machine, or you may see some variation of that. But the idea here is that if you try to do int of 2.1, for example, truncation means it's going to chop off the decimal part, right? So int of 2.1 will give you 2, int of 2.5, you may be like, oh, well, that should round up, right? 5 and above, I should round up. I think it's going to give me 3. Nope, it's going to chop the decimal point off. Now we're going to try int of 2.9. Okay, so bigger number, that should round up to 3, right? No, it's just going to chop it off. So here I'm going to give it some more 9s and see if it will round up, and it does not. So here I'm testing this out on my system. If I really force the issue with all these 9s, I can eventually get it to flip over to 3. But in general, when you do the int, it's basically going to simply perform truncation, that is simply cutting off the decimal. You should not expect it to be rounding, and any number of decimal places we should be using for the purposes of this class would be well within what is not going to round, and so you should expect that truncation is going to be what happens when you use the int coercion. Generally, the whole number is simply going to be retained. All right, so let's see some other cases. Int of a string hello. Well, that doesn't really make sense. I don't know what I could overload that to do, and neither did the author of Python. So it says that invalid literal int with base 10 hello, which is Python's way of saying I cannot convert hello into an integer. All right, well, maybe I could do a float. Well, same problem, not too surprisingly. So coercion of a string or to an integer or a float is not defined and will result in the errors as we have seen here. There's also the thing about implicit coercion, which I've alluded to a moment ago. If an expression has a type different from one expected, Python may try to convert it automatically by calling a coercion function for you without providing any indication to the user that this is what's happening. It's just kind of sneakily doing this behind the scenes, trying to be helpful. Well, isn't that nice? Well, sometimes. Implicit coercion may appear convenient, which sometimes it is, but it could produce unexpected results, especially when combined with overloading, because it may coerce some things and then they may be defined to behave in a certain way due to overloading, and you never know quite what will happen next. Consider the print function expects a string for input, but if it finds something else, it silently calls stir on it. So how is it that print 2 plus 2 actually works? Print should only work on a string, like I told you, right? Or did Professor Thayer not tell the whole truth? Well, the reason is that this is an expression that is going to resolve to an integer. Do you agree? 2 plus 2 will resolve to 4, which is an integer. So print should not be able to print 4, but it automatically coerces it. So it is going to do something like this: print stir of 2 plus 2. So it will coerce the 2 plus 2 using the stir, which will then mean that what Python actually sees when it gets to print is the so this will send it the string 4 instead of the integer 4 is the point here. So there's also Python math functions from a module. To access pre-existing math functions in Python, you can use the import command and the name of the module containing the functions that you wish to use. So suppose we want to use the math functions. You can do import math. This is going to mean that you can now import more functions than are simply available in the base Python. Why would we do this? Well, can you envision how many different functions have ever been coded for Python? What if we incorporated all of them in Python? Well, when you download and install Python, it's going to take forever, and it's going to take forever for anything to load because all of that would need to be processed. So this is why we move things out into the other modules, and we have the base code for Python, and we load that all the time, and those are the tools we're learning and focusing on in this class. And then there are other things that you could import in. And when you learn how to write functions and do object-oriented programming, you can also write your own that you could import in and use them. So the math module allows you to access additional math functions such as sine, cosine, tan, pi, right? This is the value of pi out to some number of decimals, some trigonometric functions, and there are more in there too. To call a function, you type the name of the module, a dot, and then the name of the function you wish to use. So I call this the dot notation. So we would do math dot log 10. This is going to be the logarithm in base 10, which, by the way, on your calculators, if you're using scientific, is probably just the plain log button. In Python, you need to use log 10. So this says 10 to what power will be 100? That answer, of course, is 2, because 10 squared is 100, 10 times 10. We will work with the math functions in the lab, so you will get some practice with them. You can also compose functions with the math module. So similar to the use of parentheses that we've seen, Python can return a value from one function and pass it on to another. So 5 times the value of 3 plus 1 overrides the order of operations and enforces the 3 plus 1 to be done first to make that 4. And then, so the 3 plus 1 gets parsed first and resolved, and then it gets multiplied by 5 to give us the 20 answer. You can also do the same thing with the math module. So suppose you wanted to do some of these crazy calculations. I don't know why you would need to do this one, but I'm just gonna make one up. Suppose we wanted to take the square root of 4 and then multiply it by the sign. We would make use of the math module. Again, we would use that dot notation. So it's important that you always remember to import math 1 first. You only need to do it once per session. So if it's in your script, you only need to import math once, but you need to be sure to do it. So now we would do a math.sign of math.square root of 4, just like so. Python will take the square root of 4, which is 2, and then it will take the sign of 2, which gives us this 0.9092 number right here. Python has dynamic typing. A variable has an associated type, but the types may be able to be changed by using the coercion functions as we've just been looking at. The same variable, therefore, may have more than one type in the same program. So how will you know which type it has? Although this is possible, it should be used with caution. It is not a good idea to be changing the type of your variables just however you like. You really should be thinking, do you really need to do this? Now, knowing the type of your variable at all points in the execution of your program is very important. So let's just see an example. X equals 5. What did you suppose the type of this is? Well, it looks like an int to me, and Python agrees. Now I'm going to do an explicit coercion. This is me coercing X into a float. So this is not the same as implicit coercion, which happens without me actually typing something. Here, actually, it's been typed X equals float of X. And now we check the type and we see that it's float. So X has both been an integer and it has also been a float. X has had 2 different types in the same program. Its type is dynamic, that is, it's changing, as opposed to static, which is staying the same all the time. If you have any other programming experience, you may likely have encountered static programming, which is a feature of many other programming languages. All right, so here we can rewrite the print statements to make any coercion explicit. What will Python return, and will any make any errors? So let us keep in mind that print can only operate on strings. And so when we do print 2, we will not get an error, and that is because Python is implicitly coercing 2 into the string of 2. Same will happen with the float of 2. We have seen print of 2 plus 2 already, where this will actually get coerced into, well, that will get resolved to 4 and it will get coerced into a string. Here we have explicit coercions into 2 plus float of 2. These are explicit coercions, so this will be 2 plus 2.0. So you have now an int and a float. Well, what will happen? The answer will come out as a float to retain the decimal values. So the int will actually get coerced to a float, which then will be added to this float, but can print the float 4.0? No, so that needs to implicitly get coerced into a string. Similarly, we have some explicit coercions here, string of 2 and float. So what's going to happen there? And we also have some of these true plus 4 and true times false. Don't forget about your substitutions. What do you think will happen? So here I've worked these out for you. Here are some of the easier ones that we've just talked about. These will explicit. So here is a print 2, right? So print string of 2 is what's really happening. Print float of 2 is really calling string. Here's the explicit call. We've seen this one earlier in the lecture. Here we're going to print int of 2 plus float of 2, which gives us 4.0, because what has happened is it is called string. Now, if you try to do this one, print string of 2 plus float of 2, we are going to have 2 as a string plus float of 2. Well, there's no coercion function to deal with the string plus a float. You could coerce the float to a string and then concatenate them, but this as it stands is not going to work. We can also try to, okay, and so we can see that that's what would be going on here, which causes the error, right? Because you cannot concatenate a string and a float. Here are some examples that involve those coercions to our true and false numeric values. Print true plus 4 will be 5. So that is doing a coercion here with the true, and it's also going to do a coercion to string, right, of this so that it's printable. Now we're going to have true times false. That'll be 1 times 0, substituting those values in. And then we are going to need to coerce these into string of true and string of false. So these are the ints that are going to coerce the true and false into their 1s and 0s. And then the str will try to make them be printable. So this is a breakout of what Python is actually doing, which it did without telling you here. All right, well then that concludes our discussion for today. Thanks so much for joining us, and we hope that this has been enlightening for your progression with the functions. We look forward to continuing on with our discussion of the functions, and we'll see you next time.